Hi, and welcome back to the Low Level Devel channel's Gameboy Emulator development series. In the previous video, we finished up the PPU, at least an early working version of it. There may be still some bugs left to fix, but in this video, we're going to focus on adding support for MBC1 Mapper, which will allow us to play many of the popular games such as Super Mario Land, Mega Man, Zelda, and others. So let's get started. So we're going to jump right into the pan documents here, and let's go down to cartridges, and let's see, we have the cartridge header, which we're going to need, and then MBC. Let me open that up on a separate one. So this is the cartridge header, which we'll probably need to reference again, but MBC and MBC1, this is the one we're going to focus on mainly here. So MBC1 is a mapper for mapping registers and ROM data, so we can do banking and all that. So it supports up to 32 kilobytes of RAM. A lot of good information here. I'll just kind of go briefly over it. This first section is on memory, 0 to 3 FFF. This is all read-only ROM bank X0. 4000 to 7FF is banks 1 to 7F. And that's read-only again. And then A00 to BFFF, this is actually the RAM banking section. This is where you can have up to 4 RAM banks, so up to 32K. And this is often battery backed too. So if we look back here at the cartridge header, down here, you can see like this one specifies it has a battery backing it. So we can use that to determine whether we want to battery back or save our data. Okay, let's see, what else does it show here? Yeah, it's got the available RAM sizes. And so down here is registers. This is where you write. When you write, it's going to be for a register. So 0 to 1 FFF is actually the RAM enable register. Writing to any of those addresses is going to do the same thing. So if you write a 0, that's essentially disabling RAM, and if you write a 0A, that's enabling RAM. So 2000 to 3FF, this is the ROM bank number. So when you write any value, when you write a value to any of those addresses, it uses this 5-bit register. Higher bits are discarded, so if you have more than 5 bits in that value, it's just going to ignore them and just use the bottom 5 bits. And let's see, there's a lot of extra information here. There's some special cases for handling larger carts, and that's mostly related to multi-cart things, and I'm really not going to focus on those because I want to kind of keep it simple, and using the simple approach will handle probably 99% of the ones that use this. Another thing here is when you write 0 to this value, it treats it as 1. So we'll handle that in our code as well. So 4000 to 5FF, when you write to that, it's the RAM banking number or the upper bits of the ROM bank number. But those upper bits we're not going to deal with. We're just going to deal with the RAM banking number, because those upper bits are just, again, special cases for large multi-carts. So then 6000 to 7FFF is the banking mode. When you write 0, it's the ROM banking. When you write 1, it's RAM banking, or advanced ROM banking, which again we're not doing. So again, we just want to keep it simple, so we can support most of the cart types. And this down here is some extra stuff on multi-game carts and stuff, but I'm really not going to deal with those again. So now let's go on over to the code and we can look into how to implement this. So to start out with most of this is going to be in the cart.c file. To start out with, in our context, we'll add some extra fields here related to the MBC1 data. I'm going to start with RAM enabled and RAM banking. These are just flags. Let me get rid of this junk. Okay. Alright, so now we're going to have the ROM bank X, which is going to be the second banking of ROM. And then our ROM banking mode, We're going to have our ROM bank value, our RAM bank value. These are read from the register. Then we're going to have our RAM bank, which is going to be our current selected RAM bank. And then we're going to have our list of 16 different RAM banks. So these are going to be all the RAM banks that you can swap between. So now let's see for battery. We need a couple things here. First of all, just a little flag to say whether it has a battery or not. And then a little flag to say whether we need to actually save that battery data. The current bank. All right. Okay, so now let's start by creating a function. I'm going to say cart needs save. This is going to return that needs save because we're going to actually use this function outside of the cart class. And then we'll add another one. Let's say cart MBC1. It's going to return whether this cart is an MBC. So if the ROM type is 1, 2, or 3, then it's going to be an MBC1. So I can use our between macro. Type is between 1 and 3. Then it's an MBC1 cart. Okay. Alright, so next we're going to, let's scroll on down here. So we're going to create a cart battery. This is just going to return whether the cart has a battery or not. No, not header. ctx.battery. Oh, ctx.header.type equals 3. So 0, 1, 2, 3. That means it has a battery. There are ones for other types, but for now we're just dealing with MBC. So MBC1 only for now. So let's scroll on down here to the cart loading. So before the cart loading, I want to create a function to set up the RAM banking. I'm going to call this cart setup banking. So if you remember, let's see, in the RAM size based on the type of cart. So if the RAM size is 02, that means it has 1 bank. If it's 03, that means it has 4 banks. 04, it has 16 banks, and 05, it has 8 banks. So it's going to have a max of 16 banks. So that's where that 16 came from in the context up above. So I'm going to loop through I equals 0 to 16. And then for each of these, what I'm going to do, say RAM banks, first initialize it to null, that pointer to null. So if the ctx.header RAM size equals 2, if you remember, that means it has 1 bank. 2 means it has 1 bank. Yep. So if it's 2 and I equals 0, that means this is actually a valid RAM bank. Then I'm going to say RAM banks I equals malloc 8K. And I'm going to go ahead and just clear that RAM too. This probably isn't necessary, but I'll do it anyway. So let's include string.h since we're using malloc. Okay, so now there's other cases that we need to do the same check. So I'm going to add an OR here. Or ctx header RAM size equals 3 and I is less than 4. Because if you remember 3, when the RAM size is 3, that means it has 4 banks. Alright, so let's just do a sanity check. 3 is 4 banks, right? then 16 and 8 for 4 and 5. So in that case we can just say OR again. I'm just going to copy and paste this. So 4 and 5 is going to be, was it 16 and 8? Yeah, I think that's right. And so now after that we need to set the first bank to banks 0. So it's always going to initialize it as bank 0. And the ROM bank we're going to set to the ROM data plus 0x4000. So that's ROM bank 1. Okay, I think that's all there. Now we move on to the load section. So down here, let's see, after we set the title, let's see. Yeah, after we set the title here, then we're going to say battery equals, I think we have a function for it, cart battery. Yep. And then need save we're going to set to false by default. Let's see, what else do we need to do in here? We need to call our function for setting up the banking. So I'll just call that down here. I think that's all. Actually, yeah, let's say if CTX has a battery, let's load that battery file. So cart battery load. This is a function we'll eventually create. Okay. And let's see. So we're going to add some things to the cart.h. So let's go up to find cart.h. So cart need save, we have cart battery load and cart battery save. So I'll take those and we'll create those functions down here. Okay, void cart battery load and void cart battery save. We'll leave those empty for now and we'll fill them in later. I just want to have placeholders for them. Okay, so now the cart read and cart write, those are going to need to completely change. So to start with, let's see, let's just get rid of this. So in cart read, let's see, the first thing we're going to do is read just the first section, which is always going to be static. So if address is less than 4000, then we're always going to return that ROM data at the address. So if cart is not MBC1, let's just return an error. Or just return FF for the data. Now I'm going to mask the address here with 0xe000. That'll let us know if it's anything in that range that starts with A00 to B1FF. Yeah, let's see, where's it at here? Was it that? No, it's down here. A000 to BFFF. So that's the RAM bank. And masking that will give us the right bit there. So if that starts with 0xA00, then we know that we're doing the RAM banking. So first of all, if RAM is not enabled, we're just going to return 0xFF. Now if RAM bank is not set, which really it should be, we're just going to return 0xFF. Otherwise, return RAM bank at address minus 0xa000. And finally, we'll return CTX ROM bank X at address minus 0x4000. Okay, and I think that'll do it for the read. So now let's go on to the write. This is where we're going to be modifying the registers or writing to RAM. So we'll start out with doing a quick check. If we're not in MBC1, we're just going to return, because if we're only handling MBC1 right now, and in the regular ROM only, we don't need to do anything for write. So for address less than 2000, let's go back down here. So that's 0 to 1 FFF. We have, if you write a 0, it disables RAM. If you write 0A, it enables RAM. So RAM enabled equals the value and 0xF. If that equals 0xa, then RAM is enabled. So that one's pretty easy. And then the next one would be, let's see, if address, and again we're going to be ANDing this with E000, so that'll cover everything from 2000 to 3FFF. And remember, that's a 5-bit register, so we only need the bottom 5 bits. So I'll say ROM bank. And let's look again here. There's some special handling here as well. So that's the ROM bank number. So, and again, if value is 0, then value is 1. That's what we saw in there earlier, that writing a 0 is treated the same as writing a 1. So now we're going to AND equal with 5 bits, because we only want the bottom 5 bits. Okay, so now we will do CTX ROM bank value equals value. And let's see, ROM bank X is equal to CTX ROM data plus, now we're going to do 4000 times that ROM bank value. 0x4000 times that. Okay, so that'll give us our ROM bank X. And let's see, so now the next section would be, let's see, again this and 4000, so this will cover 4000 to 5FFF. And we're going to do just the RAM bank number. We're not going to worry about the upper bits of the ROM bank for advanced ROM banking. So the RAM bank number is going to be value and 0B1111. And let's see, so now we can say if RAM banking is enabled, then we'll actually do this RAM banking, because we don't want to do the RAM banking if the RAM banking is not enabled, even if they are writing a value to this. So if the RAM banking is enabled, we're going to say RAM bank equals CTX RAM banks and the RAM bank value. Okay, and actually let me look again. Was that 4-bit register? No, it's a 2-bit register. So yeah, because the value is from 0 to 03. So let's go back and change that. This should be 11. Yep. Okay. And that's all for the 0x4000 section. So now the next one would be E000 equals 6,000. And this one would be, let's see, the banking mode select. So that can be either 0 or 1. And we only need the very bottom bit for that, so we'll call this banking mode select. So now for this one we just want to do, let me see, ctx dot banking mode equals value and 1. So just grab that bottom bit. So RAM banking is actually going to be set if banking mode is 1, so I can just say RAM banking equals banking mode. I really don't need to do two variables for that, I suppose, but just to make it clearer, I'll just leave it like that. So now if RAM banking, now when you turn on the banking mode, it's supposed to actually change the bank as well. So RAM bank value, just like we did up there. So those are all the writes for the registers. The very last one is going to be the memory region. And if you remember, we did this for 0xAA000 up in the read section, so we're going to also have it in the write section. Yeah, here it is right here. So that's going to be RAM bank 0 to 3. And that's going to be fairly straightforward. We'll have a couple of checks here though. Let's first make sure, is RAM bank enabled? If it's not enabled, we're just going to return. We should also just maybe sure that RAM bank is set. Let's see. And now we're going to set RAM bank at address minus 0x8000 equals value. So we're just writing that value to RAM at this location. Okay, so that should be all. Actually, yeah. So if we are writing to this RAM and this is battery backed, we should probably save. So let's just say need save equals true. We could actually save on every write, but that might get a little bit excessive. So what I'm going to do is just save if you need a save. We'll check every second when we do that FPS check, and I think that's in the, let's see, PPU SM down here where we're calculating the frames per second. So we know this code runs every second, so I'm just going to put it down in here. So I'll just say, let's see, if, actually let me include the cart.h first. So if, let's see, cart needs save, then we'll say cart battery save. Simple enough. Alright, so that should work. Let's see, is there anything else I'm missing here? Yeah, actually, when we do the RAM banking, if we're going to switch the RAM bank, we should probably also save as well, if needed. So let's say if cart needs save, cart battery save. So we'll do that anytime we're switching the RAM bank as well. Alright. And that should cover it for the cart reads and writes. So now we could move on to, let me see, let's move on to those battery save and battery load. Actually, first let's try to build it. Going to make, and it looks like I messed something up, my copy and paste, and let me just scroll up. And let's find it right there. Get rid of that. Alright, make. And now let's run a game like Zelda. This is a MBC one game, and it has a battery. So if we start this up, let's see. So this one when you start up, you have your saved games. Right now, there's nothing, and I can create a new save game. Okay, so now just start it off. I'm just gonna close it, and now when we restart it, actually, there's a bunch of junk in here. All these FF24, those are all audio, and I'm not really going to be working on the audio stuff yet. I might eventually, but I'm not sure if I'm going to do that for this series or not. But so all this stuff from let's see, FF10. So FF10 all the way through, I think it's 3F. These are all audio. So I can pretty much ignore all this for now, just so I don't have all this junk in my unsupported bus read and writes. So I'm going to go into my IO. Let me just copy this. I'm going to say from F10 to 3F. I'm just going to, let's say, return. We're just going to ignore sound, so we'll return 0. And the same thing down here in the right. I'm just going to return. That'll make this a little cleaner, so we don't have all this junk here. Let me just clear, make, and start it back up. So now if I start it back up, you'll see when I go to the save games, I still don't have save games. That's because we didn't implement this battery saving yet. So let's go ahead and do that. It's actually a lot easier than you'd think. Because what is the battery doing? It's just keeping the RAM around. So when you turn it off, your RAM values are still what they were before. So also I'm going to remove this proc stop, just because some games use the stop function and I really don't have a good implementation for it right now, so I'm just removing that no impl. Let's see, so go back down here. Alright, here, so cart, let's see, file name. So we're going to grab the file name from the cart. I'm going to take the file plus .save is going to be the name of the, or .battery. It's going to be the name of the battery file. So let's say fin, I'm going to make it 1048 since 1024 was the size of the file name. So it's going to be the file name .battery. So if we see that file, we'll load that as the battery file. Just F open and pass in the file name, and then WB as the permissions, write binary. Okay, so if not FP, just some sanity check here. We'll print out an error. Failed to open. And I'll put the battery file name. Okay. And actually all this we can copy and put in the load as well, because the load's going to do the same thing except it's going to be RB there. Okay. So for saving the battery, I'm going to do cart battery save on the, so once we have the file open, we're just going to do fprintf ctx dot RAM bank is the data we're going to write, 0x2000, it's the size of it, and 1, and then the file pointer. Then we can fclose, fp, and then the same thing for the read, except we're going to use fread. So it's the RAM bank writing to the file pointer. Okay, so I'll copy this and paste this up here. I'll just say fread. So we have fread to load it and fwrite to save it. Alright, so now let me run it. Actually, that fprintf is wrong. This should be fwrite, not fprintf. So let me save it and rerun it. Okay, so now I'm going to create a new save game. So at this point the battery should have saved already, because that would have written data to the RAM. Also, let me just kind of close it here and I'll reopen it. So now we start it up and we'll see, there you go, AAA. Our save game is there. Let me do a quick playthrough just to skip through this. I'm fast forwarding it. Just want to get the shield. Alright, now I'm going to go through. I am fast forwarding right now. It's not going to be normally this fast. Alright, back to normal speed. I just want to die so I can save it. Alright, so save and quit. So now let me close it, open it back up, and now here's our game, and here I am already outside with my shield. So you can see my save worked, so that's nice. Oh, and one other thing, let's go back to the cart read. I actually broke the non-MBC games here. So I'm going to change this to say if it's not a cart MBC or its address is less than 4,000, then I'm going to run that code. So that actually broke Tetris when I did it that way, because Tetris isn't an MBC game. So now Tetris is starting up right again. Okay, good. Okay, so let me go back and let me run Batman, because Batman is an NBC1 game. There's no battery or RAM in it, but this is, let me bring this up. So I just want to show you that Batman works here. Push start. And let me go ahead and run through. So just so you can see, there's more than, like, here you go. More than just that one Zelda game is working. Now we got Batman, another NBC game. There's others like Megaman and Contra. So let me just run through this. You can see my bad video game playing skills. Oh. There we go, we're dead. So let me bring up another one. Bring up Contra as a kind of fun one to play. Let's see, Contra, push start. Alright, so now I can shoot, and look, alright, I'm having trouble. I can't shoot diagonally. I can only shoot up and down. I'm supposed to be able to shoot diagonally. It looks like that's probably just an issue here with the UI code. Or not the UI, it's with our Gamepad.c. Yeah, if you look at our Gamepad.c, these are all else ifs, so I can only have one button down at a time according to this. That shouldn't be the case. I can actually just fix that by removing all these else's. So now I should be able to have any number of buttons down at the same time and get the right value. So let me make that change and rerun it. See what happens. So now I should be able to have up and right over at the same time and have it counted. And let's try. Yep, there we go. Cool. So now I can shoot diagonally, and I'm dead already. Contra's not a good game for me. So I think that's a good stop-in point for this video. We kind of showed how to do one of these mappers, MBC1 being the most common, at least for the non-color Game Boy, the old school Game Boy. I don't know if I'm going to do any other mappers. With the rest of these things, I'm probably going to go on to actually saving the state, because that's actually not too difficult to save the state and restore state and things like that. So I'll probably do that in the next video. I'm not sure how much else I'm going to do. I might get to audio, but I'm not sure. It depends on what the interest is on those things. So again, if you like the video, like, comment, subscribe, and thanks for watching.